rounded to 1.106.
Yep.
Right. You chose 9 because there's standard deviations almost 9?
Yep.
Okay, but why?
What do you mean?
If delivery increased by 9 units.
That's the standard deviation.
Or more
Right,
standard
we just
deviation.
picked it for fun, really.
Oh,
But if it
okay.
increased by 9 units,
Mhm.
then that's what would happen.
Right,
So one standard
because he was,
deviation.
Which is
yeah,
one standard
because
deviation
he was
in this
showing
particular
that
case.
although the P is 0.009, that 1.1 doesn't seem very much different from 1, but showing that when
But
you
it is.
exponentiate it,
Into something meaningful that would
Right.
actually
So we're
happen.
looking at, I mean, because you can say, oh, so given a unit increase, it results in a 10% increase in the odds of death. Well, that seems kind of trivial,
Mhm.
right?
That's on a scale
But if
of
you
100.
consider it that it's a 0 to 100 scale, so that one for just a 1 unit, individually 1 unit increase results in a 10% increase in the likelihood of death. And recognizing that that 10% increase multiplies exponentially across when we start adding things on, right? So that increase from 1 to 2 isn't, and 2 to 3, we're going to jump from 1 to 3. So if we're just running in 1 unit increases, then that's what it is, right? But it's the same sort of one, it's the same unit increase, right? So you're taking this times this times this times this times this, right? So it's not, if we say a 9-point increase isn't going to be 9.99 increase my odds, it's going to jump it way, way up there, right?
Thank you.
No problem. Other questions about this? All right, cool. Last thing that I want to do, so let's say that we are unhappy with our walled test for depravity. Let's say that we have high moral standards and want to maintain our best statistical tests, and I recognize that if this was statistically reliable with my walled statistic, it's going to be statistically reliable with our best practice intervention here, but it doesn't matter, I'm going to go through and do this anyway, right? And so what maybe I want to do then is I'm going to go to Analyze, and first. Okay, so my regression, binary logistic. But what I'm going to do is I'm going to take depravity out of the equation, right? So what I'm going to do is I'm going to estimate a model with just impact, my number of impact statements, and my VIS delivery mode, right? Because what I want to do is I want a specific test, an exact test of the statistical significance of the contribution of depravity in my predictive model here, right?
And why is it depravity? Oh, because impact wasn't significant.
Yeah, impact wasn't significant. So this is just a demonstration. This is strictly for didactic purposes.
Okay.
This is not because I just picked depravity because it's a category or the continuous indicator that was statistically significant, and so
Right.
it just makes it easier to do that.
So if VIS was continuous and it was significant, you could have chosen that instead.
Yeah, yeah.
Okay.
You
Or
can do
if
this.
it was VIS and it was approaching significance,
Yeah.
that'd be a
Yeah.
good reason.
Or you can do it. I mean, I could leave out
The other two categories?
yeah. I can leave out any predictor I want.
Because what you're doing is getting an LL difference.
Exactly.
To look at one predictor significance.
Exactly. What we're doing
Okay.
is going through and sort of manually going through and sort of looking at the log likelihood difference here. So what we're going to do is I'm going to run a model regressing our sentence or the log odds of sentence onto impact and our categorical delivery. Right? And if I go down through and I take a look, my log likelihood for my model with only what happened? We're not getting the same. must have fooled around with this a little bit.
I got what you got.
You did?
On the screen or on the
On
page?
the screen.
Okay,
Yeah, I got what you got on the screen, not on the
Okay.
page.
I need to go through this. It looks like I have an old tables in here. So make a note that the stuff on your handout, you're on the log likelihoods there a little bit off. But no matter, we can still run through and take a look at this, because what we're going to do is we can go through and say, all right, so we can go back out and say for our model, that my full model is right. I don't know what happened with this. Okay, so my model with just my two predictors in here gives me a log likelihood value of 156.713. Right? Minus, and my model with all of my predictors, with VIS in there, right? So this is my model, whoops, no depravity, right? This is the log likelihood, the -2 log likelihood for my model without depravity in there, right? But my -2 log likelihood for my model with depravity, 146.519. Okay. Someone tell me what the difference between those two is.
146 is with depravity, right?
146, yeah.
Sorry, gosh, I need to write every step down or I lose it.
Nope, you're good.
10.19.
10.19? Is that what other people got?
10.19.
Okay.
10.134, but it could be my error.
No, totally easy. 10.194.
194. Okay, cool. So we got 10.194.
There we go.
Okay. So again, I guess people at home, again, what we've done is we've taken the model log likelihood for our model that has just VIS and number of VIS delivery and the number of impact statements, which gives us a log likelihood of 156.713, and then we're going to compare that with our full model that has depravity in there, right? And so my log likelihood for that is 146.519, gives me a log likelihood difference of 10.194. And then what do we compare this against, Candace?
A chi-square with 4 degrees of freedom.
There we go. Judy's got it. 1 degree of freedom.
Wait,
Why
what?
1 degree of freedom?
Because in this case, what we're comparing is the with like the addition of depravity, so it's just
Oh,
that
right,
one.
that just, right, yeah.
Yep. Perfect. Right? And if we wanted to go through and take a look and determine how many degrees of freedom we would have here, go through, look at degrees of freedom here is 4, minus degrees of freedom for our full model is going to be 5. Gives us we've got 1 parameter difference between these two, and so that's going to give us our critical. So our chi-square critical for 1 degree of freedom is 3.841, right? That much larger than 3.841, right? So we've got a clearly statistically reliable effect. If we go through. So chi-square 10, what is it?
10.194.
194 with 1 degree of freedom. gives us a p-value of 0.001, right? So you get a, right? And so even for this, right? Even for this, we didn't need to test this because it was already statistically reliable with our walled, right?
Mm-hmm.
But still, our walled p-value was 0.009. We're even still seeing a reduction here in terms of at 0.004. Okay, and so again, this is how we can go through and start comparing nested models to get a specific test of whether or not the addition of this one variable starts to go through and make a reliable difference. Now, if we go back up and take a look in our full model, we've got our Lagrange multipliers, right? Our score test here. Remember, this is our intermediate test. It falls somewhere between the walled and our log likelihood difference. We get a depravity p-value of 0.009. So that's actually not a whole lot different than walled. The idea being, if we were to exclude from using a Lagrange multiplier, the score test, so what would be the reduction in our model given the exclusion of depravity, right? Now, if we wanted to go through and do the same thing, get a specific test of our categorical VIS delivery mode, we could do the same thing too, right? We could go through and we could run a model with our two continuous predictors, leaving out depravity, compare that against the model with run the two models with our continuous, leave VIS delivery, our categorical VIS delivery out, and then compare that log likelihood of the model there against the log likelihood of the model with VIS delivery mode in to get a difference there. How many degrees of freedom would we be testing that against, though?
Well, there are 3 different categories, right? So
right. 3, right? And so if you want to go through, if you want to make sure that you're strong and solid on that, take the degrees of freedom from your full model, subtract it from the degrees of freedom of your restricted model, and that's the difference in your degrees of freedom. That's what you're going to test your chi-square against with this. Okay, and so this is something that will continue to come up. If you go through and you start getting into structural equation modeling and things like that, this chi-square difference test is a big part of going through and testing models and sort of determining whether or not we need these within SEM. A lot of it is, do we need all these parameters, or can we start fixing some stuff to 0, and does that appreciably decrease the overall model fit? Here, what we're looking at is sort of, does the addition of this increase our, or sort of substantially decrease our log likelihood? But again, this is going to be our test. So wanting you to know how to go through, know what these values are, what they represent, and how to manipulate them appropriately to get strong tests of individual coefficients, overall models, and things like that. Okay? Questions?
Yes. So you could do this test with sets of predictors if you wanted.
What's that? Oh, yeah.
You could do this with sets of predictors if you wanted.
Absolutely.
I mean, doing it with a categorical variable is essentially doing it with a set of predictors.
Yep.
Right?
Absolutely. Absolutely. And so I could go through and I could say, thinking about using this as the same thing as like a hierarchical model, right?
Mm-hmm.
Where I want to say, all right, does the inclusion of this set of predictors contribute to the predictive value of the model? Absolutely, right?
Mm-hmm.
Because you always want to make sure you've got a full model that has everything in it, and then the restricted model that's only having a subset of those. What you wouldn't want is in your restricted model to have a variable that's not your full model, because then that's going to be weird. And your degrees of freedom wouldn't correspond the way they should. You would probably catch that if you were. You might end up with, yeah, it wouldn't pan out correctly. So, but you can go through and start to do these. And people who use a lot of categorical data analyses, there's a whole lot more that you can do with this. This is just a very, very basic introduction to logistic models. But we'll have you go through, play around with these a little bit, work on and practice interpreting these coefficients, and then take things from there. Sound good?
Mm-hmm.
Questions on this?
Argue later.
All right, well,
Yeah.
let's call it a wrap. Let's not worry, unless people want to get into repeated measure stuff.
I'm,
Stephanie's
I'm
tapped.
gonna do it anyway,
tapped.
so, yeah.
How about this? The first part of it is all pretty much the same thing because we just kind of went over it already in the ANCO stuff. Actually, you know what? Let's not worry about it. We'll catch up with everybody. We will sort of get everybody on the same page. These repeated measures analyses are going to be kind of a bear in terms of sort of we're going to close out sort of with these repeated. They're just kind of complicated analyses to go through, and so we'll get everybody. We'll start with everybody, get everybody on the same page. But the first half of that presentation is going to be pretty straightforward because it's just reviewing sort of our ANOVA models, partitioning variability into within and between and things like that. We'll sort of sectioning out a repeated measures component of that and sort of use that to increase the power of our design. So, but we can cover that on Wednesday when I get back. So, sound good? Awesome. Hey, thank you guys so much for coming. I've posted data sets and problem set for problem set 6, so you can go home, go through, get started on that. Not tonight, don't start. Or if you want to do that, if it's fresh in your mind, you're like, nope, this is a good time to do it.
Is there any repeated measures on it?
What's up?
Are there any repeated measures on it, or have we covered
No,
everything?
no,
Okay,
no.
so we've covered everything.
Yeah, this is all straight up logistic stuff.
That's what I was hoping.
I'll probably come bug you in the morning,
Okay, that sounds good.
remind you. I appreciate it.
No problem.
Judah, may I have a ride home?
Of course you may.
Thank you.
Steph, do you?
I appreciate that. I thought the session started at 2 and ended at 5:30. So I was standing around and Josh needed me wandering the halls and just doing. So I walked home at 2 and got my